Now let's get starting. Good afternoon and welcome everyone for attending today's session about real-time APIs. First of all, please have a look on the disclaimer. So, my name is Michael Myra, Senior Customer Success Manager at Refinitiv, and I'm really excited about this session. Today's clients' needs, getting new data packages, digitization, cloud journeys, ESG data, all these themes will lead us to provide new APIs to clients to enrich their workflow, to ease the use of the data, and to lower down the TCO. I like to thank you for your interest, and I hope you will benefit as much as possible from the next 45 minutes. Let's have a look on the agenda. In this session, our product manager, Tirthankar, will run you through a quick rebranding overview, followed by a demo with some code examples from our development experts, Wasabi and Uma. How to migrate from legacy to strategic APIs. And finally, Tirthankar will give you an outlook on the API roadmap for 2021 and 22. Before we begin, just in keep of housekeeping, you are all on mute during this session. And please feel free to raise questions via the chat. We will have enough time to answer your question after the presentation. Otherwise, we will come back to you answering your questions per mail. So with this, I like to hand over to my colleague Tirthankar.
Thank you very much for that, Michael. So my name is Tirthankar Baumik. I'm the product manager on the real-time APIs. I'd like to begin with a quick rebranding reminder. So as a result of our separation agreement with Thomson Reuters, we cannot publish code with Thomson Reuters references. Therefore, we have released rebranded versions of the API libraries that do not contain any references to Thomson Reuters in namespaces or in any other form. This was announced last July 2020, in a product change notification, which is shown on the top of your screen, 12072. And when you get the presentation, you will be able to click on that link and have a look at that notification. It should also be available on your local MyRefinitiv account when you log in. So this PCN essentially requested customers to migrate to the rebranded APIs by 31st of July this year, 2021. Some customers have migrated, and I'd like to thank customers who've already migrated to our rebranded APIs. The rebranded APIs full support is available as normal. The non-rebranded APIs will continue to work. You will be able to connect with the non-rebranded APIs to our real-time infrastructure and subscribe to real-time streaming data. There is also full support available for the non-rebranded APIs. You can report problems to us. We will investigate, we will analyze, we will replicate the problem or help you replicate the problem, and we will recommend workarounds when it's possible and feasible. However, fixes, if a code fix is required, that will only be provided on a rebranded version. Now, rebranding, I see rebranding as an opportunity. Rebranding is an opportunity for customers who are still on legacy APIs like the SFC and the RFAs to migrate to a strategic RT SDK or the Websocket API. Now my colleagues Wasabi Levendel, who is the API development manager, and Umar Nala, who is a developer advocate, will guide you through the benefits of moving from a legacy API, SFC or RFA, to a real-time strategic API. They will also deep dive into the factors that you need to consider when choosing your API to migrate to, choosing which API to migrate to. They will also give you a demo where you will be able to see the APIs in action side by side on an integrated development environment. And this is where some of the benefits will be self-evident. So with that, I hand over to my colleague Wasabi.
Thank you, Tirthankar, and welcome everybody to the migration segment. Umar and I would like to go through some of the key benefits of migration. So let's get started with the first one here about performance. So you might be asking yourself, I have an SFC market feed API or an RFA market feed API, RFA OMM, which we're calling legacy APIs. Why should I be moving to the strategic APIs, such as RTSDK, real-time SDK, or WebSocket API? And one of the key factors there is high performance. So how do we achieve higher performance? With SFC market feed in general, the wire format, it's basically string based. With the strategic APIs or anything based off of OMM, you're now able to use a binary format, which essentially reduces your overall packet that's sent across by anywhere from 50 to 70%, giving you that bandwidth savings right off the bat. And moreover, if you have cascaded RTDSs, which are Refinitiv real-time distribution systems, when you have this, when you're able to make use of that bandwidth better, that translates directly to higher capacity, becomes much more obvious during market volatility and or at market open. You may also say, well, the market data distribution systems currently do support market feed and the translation, but you are spending CPU cycles doing that conversion from market feed into the binary format. And rather than do that, you could be using those CPU cycles for essentially gaining that capacity. So benefits all around in terms of higher performance that can translate directly into not just throughput efficiencies, but also in efficiencies in terms of the RTDS that you may have deployed and getting back some of that capacity and savings directly as a result of that. So that's market feed to OMM. What about RFA OMM to RTSDK? What is something, what's a benefit there? So with the RFA OMM to RTSDK, you would get at least equivalent performance, if not better, especially when it comes to Java. And we have improved the dispatching models there. We now provide a user dispatch as well as an API dispatch. So the dispatching is handled for you by the strategic API. And a direct result is that you're doing less within the application, and it's much more efficiently handled in terms of reading and writing to the network.
Okay, in terms of the RTSDK, the one that's most used by most of our customers is the Enterprise Message API, known as EMA, which is an ease of use layer built on top of the ETA, which is the Transport API, which is the one that's used to actually develop our ADS, ADH, and so on. So what are the benefits of using EMA? Well, it's much easier to learn for new developers, which is quite important in dealing with developer churn that most organizations experience. Now, it's easy to learn, not only because it's a simpler API, but we also have much better resources for all the strategic APIs, not just EMA, in the form of tutorials, articles, examples, webinars, and so on, which we continue to add to on an ongoing basis. We're always adding new stuff to GitHub and to the developer portal. There's also less code to write. This is because much of the default functionality in EMA is implemented behind the scenes. So you only have to use 1 or 2 lines of code to deliver equivalent implementation of maybe 20, 30, 40 lines of RFA code. Also, the EMA also offers flexibility so that if you want to override some of that default behavior, you can still also do so. It's not kind of tied down or locked down. This also means that there's less code to maintain in the long term. So that's another key benefit of that. Then the next major benefit that a lot of our customers are realizing, because it leads to cost of ownership savings, is a native cloud support. So this is one of the major benefits of the strategic APIs over the legacy ones. So using RTSDK as well as the WebSocket APIs and the RDP libraries, you can connect directly to the cloud and host your application in the cloud. You can also have possibility of direct connection with the cloud between your application and the Refinitiv data source if required. So it's a kind of like cloud-to-cloud connection if required. We also have support for different regions, and the endpoint discovery allows you to identify the optimal host for each region and also kind of removes a single point of failure. And the native cloud support, it doesn't just cover consumers, it also extends to contributions. So it allows customers to do away with their deployed contribution servers and the associated costs and just contribute securely to Refinitiv contribution channel over the internet or by delivery direct, again, having potential cost savings. And we also have simplified configuration. So as with the default functionality behavior EMA, the EMA config also adopts a default configuration for almost every single parameter. As you will see shortly from the demo that the code that Vasavi will show you, you can run up an EMA consumer by simply providing a deployed host and username in your code with no need for an actual configuration file. However, if you did want to tweak the configuration for, say, performance tuning and so on, you can start with a flat file, and then as you use the same schema, you can easily re-implement that flat file configuration as programmatic, say when you're ready to deploy to a cloud or container where you want to minimize dependencies on things like, config files and so on.
Absolutely. And if you are interested in doing containerized applications and don't want to bother with the config file, you can certainly rely on defaults for most of the configuration and or have your config in programmatic or do programmatic config rather than rely on the file config. So another key benefit are the new capabilities that we are adding to the strategic APIs. Of course, there's encryption available with RFA as well, but we now have encryption available with OpenSSL, both on Linux, that works on Linux and Windows. And when you are connecting to a load balancer, let's say in AWS, you want to use that rather than WinINet connection that's available with RFA, because the WinINet actually makes two separate connections, which would two things that could be load balanced off to a different provider side. So this is critical for you to move to the cloud. In addition to that, we also have added the Websocket Transport. Over this transport, there are a few options. You can send the same binary format when it comes to data formats, or you can also choose JSON format. So again, something new that's available only on the strategic APIs. Another key benefit to using these strategic APIs are that they are open source and they are supported by an active community of users. And you are able to report issues directly on GitHub to us, which get our attention pretty quickly and get to a resolution. We do have, of course, ongoing support and new features added into the strategic APIs, specifically things like Red Hat 8 support or Visual Studio 2019, or making sure that this is qualified on the newer operating systems as soon as they are available. All of that is going to be done for the strategic APIs, whereas with the legacy APIs like SFC and RFA, which are at least a couple of decades old, we have rebranded them, we have made them available to you, but the ongoing support will remain, of course, on the strategic APIs. In terms of adding support for new compilers and OSs, we, of course, always do intend to support everything here, whether it's legacy or strategic, and give you any fixes, as Tirthankar had mentioned. So when it comes to migration, what are your choices in terms of strategic APIs? So what I'd like to do is kind of quickly introduce what we meant by RT-SDK or real-time SDK. When you're getting one single package, or you can download this from GitHub. And within that, there are multiple layers or multiple APIs, if you will, that you could write to your application to. So let's start with the bottommost layer, the Rssl. This may be familiar to you if you have been writing to RFA. This is your transport that's common to RFA as well. And of course, it consists of your transports, as well as the data library interfaces, as well as messaging and containers. So if you, of course, the difference between the RFA and within our SDK is that you get one single Rssl library here that provides to you all the capabilities to use all of our supported transports like WebSocket, Socket, shared memory, and of course multicast. And if you would prefer to write your application to a higher level, we also offer the value add layer. Now, this is where we introduce the concept of dispatching, callbacks. So once again, you'd be saving a lot of time writing that application, because you are writing to a layer that handles all of the administrative messages, such as the login, source directory, dictionary, etc. And you're also saving in terms of how you're dispatching over to the network. So it also does all of the recovery for you, and connection recovery is available here. Another layer that you could write your application to is the watchlist layer, and this is essentially providing you item aggregation, item recovery. And so if you're asking for the same item, let's say 5 times, one of those is a streaming connection, one of them is a snapshot, another one is a view, which is a pared down list of FIDs that you're interested in. All of that is aggregated over the wire for you, and the responses back from the providing end are fanned out to the various streams that are making those requests. So you'll notice that as you add these, go through these layers, the application burden is reduced to the point where it's this, but the message API, within just tens of lines of code, you're able to get up and running very quickly, and you'll see that very clearly within our demo. Again, just to reemphasize this, this is available in a couple of different languages, C and Java for the ETA portion of it, and for EMA, we have it available in C++ and Java. So also would like to take this opportunity to introduce the WebSocket API. Now, with this is not truly an API. It's more of a protocol specification with a series of examples that we publish on GitHub. Here, essentially, you're encoding a payload that's JSON, and we have some compiled APIs as well as some interpreted APIs in the examples so that you can follow those, and it's fairly relatively simple to be up and running with those. We do have examples that show connectivity into the cloud solution, the Refinitiv real-time optimized. So please feel free to click on these links when this presentation is available to you to have a look at the options there. Now, as far as resilience is concerned, this is something that you would be building into the application, whereas that is taken for granted with these APIs. Over to you, Umar, to add to.
Yeah, just one other thing I should mention in terms of the WebSocket API is, as Vasavi mentioned, you kind of have to do some of the admin and overhead stuff yourself, but we'll be releasing soon a Refinitiv data library, which is like an ease of use wrapper around the WebSocket API, but it'll also let you access non-streaming data as well. So from our platform, so things like ESG data, historical data, and so on. And that's going to be available in Python, .NET, and TypeScript versions, and it should be hopefully available end of Q4 this year or early Q1 in 2022. Thank you, Vasavi. Okay, so this particular tree I'm going to show you here, it's also available along with additional notes, etc., on our developer portal, the link for which will be shared later on, or you can get to it by searching for Legacy API Migration on the dev portal. Now, the accompanying notes explore the various criteria and factors in a bit more detail, as well as the key differences in terms of performance, memory usage, and high-level functionality. So the idea is that using this tree in conjunction with the notes on the article should help you narrow down your choice to one or possibly two of the most appropriate APIs or libraries based on your requirements and priorities. So, for example, if your performance is your highest criteria, so you're dealing with, say, hundreds or tens of thousands of items in your watch list, then your choice is going to be RTSDK, and then you can then kind of choose between ETA and EMA. If, however, say you're a Python user, then you would explore the WebSocket API and the RD libraries and so on. Also, in terms of content set, if you want just real-time streaming data, that's fine. But say you wanted non-streaming data as well, things like historical data, ESG data, whatever, then you may want to look at the RD library as well as so that lets you access streaming data as well as the non-streaming stuff. So again, this kind of stuff is explored in a bit more detail in the article, but this is just like a high-level guide to help you narrow down your choice.
And when it comes to the choice between the APIs here, other factors might be your watchlist size. That will determine if you're picking, say, for instance, an ETA reactor layer for your application or watchlist layer versus an EMA layer. Of course, ease of use is another area to consider here, and that will become, as we said, more apparent as we give you a demo of or rather the code walkthrough of exactly what this would look like. All right, so we do realize we've specified several legacy APIs here and several strategic APIs. So what I'd like to do is take a moment here to kind of hone in on a few that make sense. So, for instance, if you are an SFC user, it may make sense with the given watchlist sizes and the performance of this currently for you to migrate to EMA. We do have C++ and Java versions of that, so that's a fairly easy choice. If you are using .NET and still have, again, this is the lowest performant in the market feed RFA anyway, so when it comes to migrating from there, you may choose to go straight into the WebSocket API and consider our C# samples to do that migration. Other possibilities here are that you're interested, as Umar mentioned, in other content sets like historical pricing or coming soon chain content or snapshot content, and a plethora of other options. You may consider doing the REST requests directly to our RDP, or Refinitiv Data Platform, to get that content. So it just depends on, there are multiple choices here for the migration, and certainly a combination of things when it comes to getting the content off of REST request response and or streaming content here. You can choose based on your watchlist size, either an ease of use layer, and or if you're looking at a .NET replacement, go to something that's in WebSocket territory. Now, if you're looking to move from RFA OMM, many choices again. You can choose our most performant layer with ETA layer, either directly writing to our Rssl, or as many of our customers do, they choose the reactor layer to write to, because that does offer the value-added features and offers the failover, and soon it will also offer warm standby features. So that's certainly an option. And depending on the watchlist size here, you may also choose to go straight to EMA and make use of our ease of use API. Same applies to WebSocket API if the watchlist size is low enough and you prefer to use one of these APIs to be up and running. There's plenty of sample code on GitHub to do that. So hopefully this gives you an idea for some optimal choices when it comes to migration. Within the rest of the presentation, we'd like to focus that on a couple of different choices. So we will talk through the SFC to EMA migrations and RFA to EMA as well. And if you'd like to see any further discussions or any other offshoots of this, please feel free to add some comments or add some questions into the chat here, and definitely reach us and otherwise. So over to you, Umar.
Thank you. Yeah. So as you can see from this slide, EMA supports the most commonly used functionality of SFC with several key enhancements, i.e. the high performance data format, the cloud connectivity, i.e. the ability to consume data directly from the cloud, which again, could lead to cost reductions for those customers who don't necessarily need a deployed or managed RTDS. Can we go on to the next slide, please? This slide shows a few more benefits of EMA over SFC, such as full depth order booked, as well as batch item requests and field filtering to reduce the bandwidth usage and payload processing even further. And as mentioned before, EMA also supports contributing data directly to the cloud, which again could help realize cost benefits and remove contribution server and software and so on from your site. Obviously, I'm not going into much detail with these tables, but the source material for this again is available on the developer portal under the Legacy API migration search. So you can kind of see this with additional notes and comments, and we'll share the link later on at the end of the article. Next slide, please.
Here, what I'd like to do is call out maybe some things that you might find as missing from the strategic APIs. So that would be this time series data. But what you are getting by going to RDP here to get the historical data is a much more feature-rich data set. And it's a simple REST request response. So that could be in your application written to EMA. If you are using RSL fields or chain handling, with RSL fields, we do have an example code within EMA that shows you exactly how to get an equivalent there. With chain handling, we have helper classes and an extensive tutorial on developer portal. There's a link to it over here for you to consider. But overall, we find that about 95% of our customers aren't really bothered about these differences, but certainly we would invite your feedback to understand if this is important to you when you're considering migration from SFC to EMA. And some of the ways to contact us that I'd like to call out. As mentioned, you can make a request on GitHub, in the issues section of the GitHub. You can, of course, contact our product owner directly, Tirthankar. And of course, you can go to developer portal to look through a lot of these tutorials, quick start guides that will help you get up and running quickly. And there is a Q&A forum here as well for you to ask the questions or look up any of the answers that have been previously provided over the years. There's a very active and very skilled community of developer advocates that are constantly looking at this to give you the answers.
Just wanted to add, obviously we said the helper class is available soon. Now we actually just published them just earlier today, about a couple of hours ago. So if you go to GitHub, you'll find the EMA chain expander class is now available on there. So that's on there, that's fine. Okay, I can move on, thanks. Okay, so I'm just going to now take control of the screen so I can share the code and so on, if you bear with me. There we go. All right. So I'm just going to move that to there. Right, can you see my screen, Vasavi?
Yes, I'm able to see it.
Okay, great. That's excellent. Okay, so hopefully everybody else can as well. So, what we're actually going to do today is I'm going to show you some SFC code and then compare it to the equivalent EMA, just so you can visualize how easy it is to migrate from SFC, C++, Java to EMA. Again, due to time constraints, I'm not going to cover the absolute basics. However, you can find more detail in the migration notes, again, which we'll kind of share a link to later on. So I'm going to start with an SFC subscriber because that's the most common usage scenario for most of our SFC users. Now, based on past experience and so on, one of the most common examples that our customers tend to use as their starting point is one called RecOpD, which is available in the SFC C++ SDK. So let's just kind of jump right into this. Essentially, absolute basics, you create a connection to the server in SFC using, say, record service, and then typically you'll be implementing a callback client. For example, here we've called it record update client, and in there you'd be kind of making a subscription request to the server, and then you'd have various callback handlers in there, one to handle when you get a refresh message back from the server with a payload, likewise if you get an update from the server, or things like if the record goes stale or not stale when it recovers again, you get the full image sent back to you. There might also be some other handlers you'd have to implement. Things like if a record is closed off for whatever reason, if it expires or some such, or there's some other status information coming back from the actual server for a particular instance. You can see it's fairly straightforward in SFC, and I'm going to kind of pass over to Vasavi, who's going to talk through the EMA equivalence. You can see it's not a million miles away in terms of what you have to implement in EMA compared to SFC. So Vasavi, can
absolutely. So, thank you, Umer. So on the right side, in contrast to what Umer just covered with SFC, is a EMA consuming example, equivalent of a subscriber. In this case, you're looking at the C++ example. I'll draw your attention to the bottom half of this, which is basically where you're instantiating a consumer, specifying your endpoint, which is defined by your host and port, and a DAX user for your entitlements. And that's it. When you've done that line, essentially that's in the background, making the connection to that host and port and going through the login, etc., the administrative messages. And then the next line, which is basically registering client, you're specifying which service that you'd like to receive data from and the item that you'd like to get the data for. So with that, essentially you're, yeah, thank you. If you, as a consuming application, all you're doing is 2 lines of code here, followed by setting a few callbacks for retrieving different kinds of messages: refresh message, update message, status message, and so on. So once you have made that request for, in this case, you are equal to, that will give you, that will come back. In this case, you're making a streaming request, so it'll give you a refresh message. It'll call you back on the on refresh message callback. And here you could easily go into the decode function. I won't go into too many details there, but basically it's, you'll iterate through the response to get the fields and do your processing with those fields. And if you did, as we did in this example, specified a streaming request, you will of course get updates shortly after the refresh message and be called back on the update message, on update message callback. If there is any stale data, you notice that there are 2 callbacks with the SFC. It's just one simple one where recovery is handled for you, and essentially it will notify you that the data has gone stale temporarily while the upstream server is recovering for you. And once that's back up, you will get an unsolicited refresh followed by updates as usual. So there's a lot less involved here to get up and running, and essentially a couple of different lines here, and then you're off to the races.
Okay, thank you, Vesavi. So the next example I'm going to look at is a posting or contribution or insert example. Again, the reason I'm going to do that is because that's probably the second most common usage scenario amongst our users of SFC. After subscription or consuming, they then use SFC mostly for inserts and so on. So again, very simple example. Again, this is one I've taken from the dev kit, SFC dev kit. So we just create an insert service, which is a connection to the server. And then I'm not going to go through the whole code for the SFC example, but essentially one of the key things I want to draw your attention to is that with SFC, when you're making a contribution to the server, you have to create what's called a market feed string-based format. So it's quite itty-bitty. You have to kind of do building up the buffer yourself manually. So essentially here we can see I've got my field IDs in string format, and obviously if you're contributing prices, typically your prices will probably be in a numeric floating point format. So then they actually need converting to a string before you can actually add them to the actual payload. So you end up, you create an insert object, set your item name and so on, use an iterator then to actually, you then have to create like a header for the actual insert record, which is all documented in the MF data that comes with the SDK. And then you have to actually start appending various bits to the actual string buffer, including the field ID, the actual string format of the price. And you keep repeating that until you've added all your fields. Then you finally have to call complete and then call the write method on the insert object, which actually sends that off to the server contribution. And then you actually have to implement various handlers, things like, if insert succeeded, insert failed, or if the service has gone up or down or so on. So you have to implement all these various handlers as well at the SFC level. So I'm now going to pass over to Vesavi to show you the EMA equivalent, so you can kind of contrast the difference between the two.
Absolutely. Yeah. So with the EMA example, just the equivalent is a posting example. And you're essentially doing the same thing that you did before. You're instantiating that consumer. And then if you don't mind, and you can register for, it's not necessary if you're doing upstream posting, for example. But if you are, once you do instantiate that, all you have to do is wait for if you scroll up a bit, Umar. Okay, perfect. So on the on refresh message, you'll see that once you've received a login, the domain type is login here, then you're free to go ahead and submit messages for posting or contributing or doing inserts, another way to say the same thing. And you can see that the submit call is just that, very, very simple. You are, because this is binary format, there is no manipulation of strings just to contrast with what Umar had shown you. You're essentially, the 25, 22 are the FID IDs here, and you're encoding the values with, in this case, reals, and then hitting submit, then that essentially does the insert. Now, when the insert's received by the far side, you will get an acknowledgement back, either a ACK or an ACK. Both of them are arrived to you on the on ACK message. So there again, it's a consolidation compared to what you've seen with the SFC insert example. The other callbacks are not terribly important here, but these are the key things for an insert, and very, very simple, very straightforward, hopefully.
Okay, so I think that's probably all we're going to show for SFC now. We're going to move to some RFA, look at a few RFA slides, and then we'll come back to some RFA code examples and compare them to EMA and so on. And Wasabi will demonstrate some different EMA examples as well, because you've already seen a consumer in EMA. So are you ready with the slides, Wasabi? Should I give you control back, or are you going to take control? Oh,
absolutely.
Great.
So okay, hopefully you can see my screen here. So in this segment, we're going to switch over to the migration possibility for RFA to EMA. Umar,
yeah, sure, yeah.
See if you'd like to go ahead.
As we saw with SFC earlier, EMA kind of supports pretty much the major functionality of RFA, along with several additional benefits. So the key being the ease of use. So as you kind of see shortly, when I show you some RFA code, you'll see just how much that contrasts with the EMA code that Wasabi has already shown you, where there's tens and hundreds of lines of code compared to the several lines that we saw in EMA. So that's one of the key benefits between EMA and RFA. Can we move to the next slide, please? Okay, right. Now, this slide shows a few more benefits. So of EMA over SFC, such as full depth order book again, obviously compared to market feed, should I say. And again, the main key benefit here is that it supports both consuming and contributing data to and from the cloud, which is something you can't do with RFA OMM or RFA market feed. Now, after looking at these tables, you may think, well, yeah, RFA OMM and EMA appear to be quite closely matched in terms of other functionality, so why should I upgrade? Well, even putting aside the ease of use, the learning and the code and maintenance and so on, perhaps even more significant is a long-term support in terms of compilers, new features, and the possibility of enhancements requests for EMA, as with all the other strategic APIs, which is not something you can continue to expect with the legacy APIs going forward. Next slide, thanks.
Once again, you may notice some of the differences here. We would like to call out some of the gaps. We've talked through the time series chain handling previously with SFCs, with the enhanced symbol list. It's available at the lower layer, the ETA reactor layer, but not at the EMA layer. With warm standby, this is an upcoming feature, so we do intend to fill this gap. With a lot of these deficiencies, again, we believe that the majority of our customers don't notice them, and if they are in fact something that you're interested in, certainly do reach out to us and let us know if this is something that you'd like for us to pursue.
Okay, so we'll kind of move back to some RFA code now. So I'm just going to take over the screen, if you bear with me. Okay, can you see my screens again, Wasabi?
Yes, I can see it.
Yeah, great. Thank you. Okay, so for the RFA, I'm going to start with one of the most commonly used RFA market feed examples, which is RFSD ticker, which comes with RFA C++. Now, the code for this example is actually several thousand lines of code. So I'm going to literally just look at the absolute bare bones of this. Again, there is a equivalent document on the dev portal. We're kind of going into a bit more detail about how RFA market feed works and how you might replace equivalent bits with EMA. But just to kind of contrast the RFA market feed with EMA, I'm going to show you the absolute basics. So here we're looking at the code to initialize an RFA market feed application. So there's so many various things you have to do. You have to create various configuration database files, event queues, a session, a market data subscriber, which is actually the interface between the application and the API. We also have to create a market data client, which is the actual callback client I'm going to show you in a moment. And then there's various initialization bits you have to do in terms of pulling in the configuration and so on. There's very bits and bobs. And the next kind of key step will be kind of creating a session. So creating a session is when you actually essentially make a connection to the server. And one of the callouts here is the session name. So that session one there relates to the RFA configuration. So that session one value there is actually is what this is referring to, and the connection session only points to a connection parameter, connections config, and in there you specify the username and the server list and so on. So that's the basic EMA configuration, SFC RFA configuration. Sorry, and this is a basic file you need to have before you can run a RFSD example or the equivalent programmatic configuration. Okay, then we have to create a market data subscriber, and then we actually instantiate a market data client, which is a callback client, before we finally start up a message loop to do the dispatching of the events. And then we actually have to create a market data subscriber as well and so on. So let me just kind of quickly jump to the actual code for our market data client. Again, this is several hundred lines of code, so I'm not going to go into too much detail. Just key things. With RFA market feed as well as RFA OMM, the data dictionary stuff that's required to unpack the data, you have to actually download the dictionary or load the dictionary yourself from a file and unpack it and parse it and so on in order to use it later on. That's something you noticed was missing from the Ema applications, because Ema does all that for you behind the scenes by default. It's something you don't have to worry about. And this is the actual market item sub object I'm going to create. I'm going to use to make my subscription requests. I'm going to kind of jump to the next kind of key function in here that you'd be interested in, is the process event. So obviously, because it's a callback class, as the events get dispatched, whenever some data or information arrives from the server, this is triggered, and then you have to kind of look at the event to see what kind of event it is, whether it's a data event or a dictionary event, connection event or service event, and so on. And then if it's a data event, for example, you'd extract your instrument name and service name, and then you'd actually even have to figure out what kind of message is contained within there, whether it's an image or an update or various other types of data events you can get. And then you obviously have to extract the buffer from the event, and then you can process the actual data itself. But before I show you that, quickly show you how you make a subscription in Market Feed. You have to set you use your market data item sub-object that I created earlier. You set a service name and an item name, and then you have to call subscribe to send a request off to the server, and specify which event queue wants to receive all the events and so on. So in terms of the actual data, when you get it back from the server, we have to use a TIB message library to unpack the buffer, and then use some other kind of helper functions to then convert that value to a string or a numeric value or whatever, because again, it is in a TIB message format. So that in kind of, in a nutshell, is the absolute basics of our RFA market feed example. Now, I can't really show you a RFA OMM example in much detail, because that probably is even more verbose, the code, and it's probably even more lines of code just to implement a simple consumer. But just to kind of contrast it with EMA, I'm just going to show you two bits of code here. So when you want to do a login request, which is what you need to do as part of an RFA or a OMM application, you kind of need 30, 40 lines of code to create a login request, which if you compare to when we were doing a login request in EMA, it was simply a single line of code. Even that's optional. It's not even normally required, but we're doing that for the purpose of the streaming, the posting and so on. So again, you see there's about several lines of code just to do a login request. And then likewise, when you make a subscription request, using RFA OMM, again, there's like 10, 20 lines of code you have to actually utilize in order to implement a simple subscription request, again, which compares to a single line of code we saw with the EMA example here. Okay, so that's probably the end of RFA examples. Obviously, Rssl already shown you EMA consumer example, so I'm going to pass back over to her, so she's going to show you a few different EMA examples for providers and so on. And again, I can't really show you RFA provider example, because even there's even several thousand lines of code involved in there. So I'll just pass it to Rssl to show you how simply to do a provider within EMA.
Great, thank you, Umar. So before I jump into that, though, just 3 quick points about the consumer. You notice that the configuration is as simple as the local host and port. Another thing that you've noticed here is that we are by default doing API dispatch, so you don't have all of that burden of having to do the dispatch explicitly here. There are, of course, examples for the user dispatch within GitHub, so please feel free to browse through that. Simplified dispatch, simplified config, and simplified dictionary handling, because a lot of that, the APIs handling the dictionary, loading that for you. A couple of different options there as well in terms of configuration, where you can either have a local dictionary, which changes monthly, or you can download it using channel dictionary, and that will be apparent if you go through the configuration, which I won't spend too much time going through right now, but feel free to look at our file config, and if there are any questions there, definitely reach out to us. So 3 things: simplified config, simplified dispatching, and of course simplified dictionary handling that I would like to call out here. So what I want to say is I don't want to spend too much time here because we're almost out of time, but with the providers, it's very, very simple. Again, you're essentially creating that provider object, waiting for some consumers to connect in, then responding back with a refresh message once you've realized that there is a, at the top there, once you do get that connection coming in and there you see a login request, and then it's just a matter of submitting the market price responses once you see those requests. So it's really that simple within the EMA application. This, by the way, the providers here, the interactive provider, non-interactive provider, would be the equivalents of the managed and unmanaged providers in the world of market feeds. So just a quick call out for that. And then I don't know if you have a Java application. Just to quickly show. So you saw the C++ application. Java application is absolutely similar. Even though there are language differences here, we tried to make this as clean as possible and give you a very easy way to be up and running and after the races to get the data or to contribute data depending on what your objective is there. So that about concludes our code walkthrough. All right, so what we'd like to do is quickly summarize some of the highlights that you've heard today. With the strategic APIs, you are getting the cost savings back to you due to improvements in performance. And we've given you many, many more options in terms of the operation models, like the user dispatch and the API dispatch. There are additional features that are being built into these APIs, such as the Websocket Transport, the encryption, the native cloud connectivity. So there are many reasons to move away from the legacy APIs that are a couple of decades old and into the strategic APIs and into the newer content sets that are easily available via REST or via the streaming APIs, of course, that we have presented here. We will be coming out with a relative performance between these APIs, especially within the SDK. You do have many choices there, so you understand perhaps in much more keen detail about which one makes sense for your use case, depending on watchlist sizes, etc. So that's it. Back to you, Tirthankar.
Thank you, Vasavi. Thank you, Vasavi and Umar. That was very, very helpful. So I'd like to spend a couple of minutes on our 2021 roadmap. So we are fully invested and committed to continuously evolving and improving our strategic APIs. We've delivered several features this year. The flagship feature has been the first one, So the ones that you see in green have already been delivered. So our flagship feature has been the first one, which is the Websocket Transport in RTSDK Java. So traditionally, you were able to use only Websocket Transport only with the Websocket API, and with the RTSDK API, you were stuck with just a socket transport. So now we've added WebSocket to RTSDK as well. So you can use all the features of RTSDK, such as session management, failover, and the various resilience features, and as well do JSON over WebSockets. The other feature that customers have been has generated great interest with customers is we've released the RWF to JSON conversion library. So this, as the name suggests, converts JSON OMM to RWF and vice versa. We released a server-side encryption, which so when customers implement provider application, they don't have to implement their own encryption. This feature will take care of that. Then we released a tool. This is just a GUI real-time market data viewer tool that can help sort of your market data support teams or developers wanting to debug issues. Then we made 2 standard maintenance releases, which essentially addressed issues reported, customer issues reported on GitHub and the developer portal. As part of these, we added and removed compilers and operating systems. Product change notifications for these additions and removals go out 6 months before. So in Q4, which is a very interesting quarter, there are a couple of very interesting things that we will be doing. So we will be implementing a warm standby in RTSDK, CC++. So this is 2 connections, a warm and a standby. And in case of problems, the streaming data connection moves to the standby connection with minimal disruption in case of failure. So that will come out. Also, as Vasavi, I think, just mentioned, although we do performance testing, we don't have a proper performance document, a performance benchmark document that we can share with customers. So that will be coming out by the end of this year or by early next year. And that will not only show you the performance benchmarks nicely formatted in tables and charts and graphs, it will also provide you with guidance on how you can tune your infrastructure further to be able to get the optimal performance from your APIs. Lastly, there is a big company-wide program, and we will be sort of upgrading the authentication on the Refinitiv data platform, which will impact the APIs. I will not spend much time on this because there is going to be organized. Refinitiv will be getting in touch with you in the next couple of months regarding this feature. So as you can see, we are making considerable investments in our APIs. We are also working at this point in time on a 2022 roadmap, and I will be able to share that roadmap with you either by the end of this year or early next year. I just want to take one question at this point in time. There's a very interesting question from Angelov about, will RTSDK have a .NET implementation anytime soon? So yes, an RTSDK .NET implementation has been talked about within the company for a very long time, but unfortunately, due to prioritization and other competing requirements, this has never seen the light of day. It is still being talked about. We may have something by end of next year. But I cannot promise anything to you at this point in time. However, the only point I'd like to make to Angelov is that if a .NET API is very important for you to migrate from your legacy API, if you'd like to migrate to a .NET API, if it's a very important requirement, please do get in touch with me. I urge you to get in touch with me. We might be able to help you out on that one.
Good. I think there's another question from Dimitar Angelov, something about permission data. So the permission data, generally you'll be using that if you're doing proxy permissioning. So if you're writing an application which connects to the upstream data server and then redistributes that data downstream to downstream consumers, you have to check their permissions and so on. So that's one reason you may use the permission data you get back in the refresh message for doing the proxy permissioning.
I see another question here about API compatibility with the different types of proxy servers for internet access. That's from Alexei. So I suspect you're probably talking about proxy authentication here. Is that if that's the case, then yeah, we did test with a few proxies and a few proxy authentications. Certainly have that information available on GitHub about exactly what's covered there. But we can dig up additional information for you and answer this directly to you, Alexei. Thank you for the question.
Okay. With this, I'm going to finish the presentation part of the session. I hope you enjoyed, and we could provide you a wide overview where the API journey will walk through in the future. So I think we do not have any more question open here in case of there is any more questions. So I think we will answer this per email. So as already said, in case of further questions, so please feel free to contact us directly or via the developer portal, via GitHub, or via our help desk. You're always welcome in this community. And as we are pretty much done before we will end up finally, so we will provide you the complete presentation per email and appreciate all your feedback about this session very much. So please use the following link we provide in the chat now and fill out the survey. Thank you very much again, and see you soon. Thank you.
Thank you.